Hello and welcome to a very special roundtable discussion that we're having today with Control Techniques. Now, there's a phrase that a week is a long time in politics. Well, how about 50 years in the drives industry? Well, there's an awful lot that's taken place. Today, I have a group of very talented and very creative people who've been working in this industry, and we are celebrating 50 years of Control Techniques. Just focusing on the inverter drives industry, how's it evolved over those 50 years?
I think in the first 20 years, maybe a bit more, I think it was moving very, very fast. The technology was evolving very, very quickly. You know, IGBT technology, silicon-based technologies were coming on board. You went from DC drives to AC drives. And I think those sort of shifts in the marketplace, and also people were just finding out what these products were and how they were used. So, you know, more and more people were adopting them, more and more we were understanding the needs of the customers and how that was going to evolve. And we had to understand how to consolidate all of that change into a product that could meet the needs of many customers, not just one or two.
Yeah, absolutely. So, Ricky, what is it that you're really passionate about at CT?
Well, at CT, every day is a different challenge. So I love the variety. But what I really like is to take a circuit that somebody's worked on and just improve it a little bit. If we can save a fraction of a penny, make it a little bit smaller, a little bit faster, a little bit more efficient, that's a really satisfying day.
Yeah, sounds good. It sounds exciting. Reese, working with colleagues, is it important to have quality engineering colleagues?
It certainly is. I mean, everyone has their strengths and weaknesses, and it's very rewarding to actually work with a team of people who all have strengths in certain areas. It's rewarding to pull it all together. At the end of the day, you end up with a product which has got a little bit of characteristics from all the different engineers in there, which ends up, a robust, compact product that meets all the requirements and regulations that we desire for the Control Techniques product.
We don't have a blame culture, though, do we? There's a problem. We work together to solve it, and I think most of the solving happens at lunchtime. You sit at a table with the right minds, right, pose your problem of the day, and it gets solved.
Yeah, right. That's excellent, and that's really important, isn't it?
Yeah, absolutely. I've not come across many other companies where there's teams of people who get on so well, I guess, and work really constructively together. And most people are really interested in what they're doing.
We mix it up quite a lot as well. So we have people who are specialist mechanical engineers or electronic engineers, and for a few weeks, a few months, they'll work on one product, and then they'll mix and they'll support the team on a different product. And we just share that knowledge around, and everybody really gets a buzz out of learning new things together and then applying it and making successful products from it.
There's always something new going on, and there's always that kind of comfort of, I'll just actually need to develop this thing as well. So you can discussing with people and knocking ideas around. It's quite along the theme, really, of just working with the company and the people within the company and your team to develop something new, something pretty established, or just looking at something occasionally quite ridiculous, like new materials or new manufacturing processes, or some way to optimize what we build at the moment.
John, just picking up on that from a company culture point of view, innovation was the thing that started the whole inverter journey. Do you think that still is as important, even though we have a mature product?
Absolutely. You know, innovation, it's about the constraints as well that you have and those constraints can come from anywhere within the industry, from your customers, from wherever, and you've got to solve still to those constraints. And you know, we talked about before, which is right now energy efficiency, sustainability, decarbonizing the world. It's such a big trend in everybody's industry right now, and that's the challenge that we have to face. And so even though we might think that the product's matured to a level, it really hasn't. It's just the shift in what is important has changed. And so these are the new things that are important in the world is what now we have to shift with our products. And I think that's exciting, that we get to work on a product that we have to then make work for the world that's also changing at breakneck speed.
Yeah, absolutely. I think that's such an important point. Luke, have there been any other surprising or unusual applications that control techniques have been involved with, things that stand out for you?
I think 17 years at control techniques and the research has shown me that I used to know in a particular area how our drives are being used. You go through periods of supporting manufacturing engineering, and then you go through periods of elevators being the focus. And I've maybe now realised that there's not a point in my daily life that control techniques doesn't touch.
What do you mean by that?
There's in the food I eat, the sausages I put on my plate have been extruded using control techniques drives. The packaging of the products I buy in the supermarkets been printed with control techniques drives. The entertainment that you go with your family on the weekends. So I've been to roller coaster parks or indoor skydiving most recently, control techniques drives. And it's gone from the entertainment to the bread and butter, daily life of food on my plate to water out of my tap. It's control techniques drives. And to be a part of that solution and really not have a full awareness of everywhere we touch, that's the surprising thing for me.
Yeah.
It's not one thing. I'm just blown away by it.
I'd like to turn to Rhys, if I may. Rhys, engineering technology is seen as cool nowadays. It's portrayed as aspirational in popular culture. Do you think this is influencing the current and the next generation of engineers?
Certainly, I think engineering is all around us. Everything we touch and use every day, there's some engineering behind it. And in recent times, a lot of technologies come to the forefront. People use smartphones, they use smart products in their houses, for example. And behind all that is an awful lot of engineering to enable these technologies to function. And as Luke mentioned, all the food we eat, the packaging we use, all these things have some engineering behind them. And in the mainstream news these days, you do see engineering projects, which gets people interested. And these days, you're only a click away from finding information on any project you like. So if you take an interest in a new infrastructure project, for example, you might think, how on earth are they doing that? You can just go on the internet and you can find out who's doing it, how they're doing it, what technology is being used. That may inspire people to want to work in those industries.
I think as well, just to add something to Rhys's point there, I think that because of the big trends in the industry around electrification, which obviously links to what we do as well, so EV cars and all that goes with that, but also energy efficiency across the industry, I think those things are becoming more commonplace in people's minds, particularly the younger generation. And I think that is what is interesting a lot of people. I mean, that sort of has two effects for us as a business, because on one hand, that gets people into more like power electronics, and that makes that more interesting because people want to kind of understand how do they get into that. On the other hand, that means that there's a lot of businesses now that are using the same skill set. So the basic skills in the UK and probably around the world are getting drawn on quite a lot to be able to solve those types of problems around electrification. There just isn't enough people to go around for the amount of business that is in that area right now.
Yeah, that's really good. Ricky, if somebody comes through with a novel idea, might be way out there, is it a culture that encourages that, or is it a culture that is hesitant?
We've got to create new ideas, we've got to develop them, and we've got to implement them. So when people come up with new ideas, it's trying to then make sure they get the time and the resources to develop that idea, prove that it can be a success, and then we see how we can put it into a product and then offer that to customers. So that's quite exciting. And then the ideas come from everywhere. We have students in that spend summer holidays working with us, and they come up with some great ideas. Some ideas that our experienced engineers wouldn't have thought of. So bringing in those ideas from the students, from our principal engineers, mixing it all together, debating it, implementing it, testing it, really is what makes a successful product.
Yeah, that's a really strong point. James, you've worked at CT for some time. The difference between the applications that you were dealing with in the very early days and the things now, does it frighten you or does it inspire you?
No, I don't think it's frightening. I think I think I've been there 25 years, so I've seen the sort of expansion in terms of the way that our products have to be connected to everything else, and we were pretty much, I'd say, or at the forefront of some of those developments going back 25 years, and we worked hard to try and stay, I'd say, perhaps ahead of a lot of our competitors in terms of the way you can use our products, the openness. So we saw years ago the need to, where possible, support the broadest range of like open communication standards. I know that's a detail, but meaning that any customer can communicate with any other bit of kit that they need to, and that trend has just accelerated away. You know, this need to be able to talk to anything anywhere in the world has just grown and grown, and I think it's going to continue to grow. So there's some exciting topics in this area, kind of to do with, you've got the idea of cloud storage, where, well, that's kind of obvious. You know, you need to be able to access data about your machine from the other side of the world, see how it's performing. But it's even growing into the idea of maybe centrally or in the cloud, if you like, controlling machines, so that you don't have a PLC or a controller locally controlling the machine. That program is written and running sort of centrally somewhere. So there's some really interesting things happening, and all of that's exciting, I think.
Reece, just a thought here with the next generation of things that we're going to see. Do you see things like AI playing a part in the next stages of development?
It's certainly taking off at the moment. And in terms of development cycle, there are a lot of tools out there which can aid you in development. And I think engineers sometimes have trouble deciphering all the information that's out there. So any tools that can help us filter down that information to make the right choices would certainly be useful. So AI may play an important part in that.
Yeah, that's very good.
I think it's starting to play a part already. So I was talking to an engineer the other day who'd used some of the sort of AI tools on the internet to get ideas for developments. That can be suggestions for things. Doesn't mean you have to use them, and it means you still need to sort of assess when they're sensible. But why wouldn't you ask something for some ideas about how to do something? You can always dismiss it.
So would this include things like machine coding, for example?
Yeah, absolutely.
Okay.
Yeah, absolutely. If something comes up with a better idea, if you don't use it, somebody else will. So you've got to be really open to those things, I think, and not. Well, you need to be cautious, but you've got to be open, definitely.
Okay. So going back to what we were discussing about new ideas and new concepts, we're in the evolution of change is very rapid.
It is very fast
at this time.
Yeah.
Do you think you've got to disturb the norm and disrupt to a certain degree?
It's exciting to do that. So there's a lot of new technologies, new semiconductors, silicon carbide devices, GaN devices. They're being used in other areas. But what we want to do is take these new technologies forward, but we still want to build in that reliability. We want to make sure they're always going to work in our products and actually deliver solutions to customers. We don't want to do things just because they're really exciting. That's fun. We always have to make things that will then make the product better.
Right.
So there's some things which we need to understand, and we find out after doing some work that they don't really fit our products, but it's been exciting to learn about it. And other things that we really must get in there, and we design them in and design the infrastructure around it, look at the manufacturing processes to implement it, and then we support the customers in using them.
Well, I'd like to thank you all for your participation today. It's been a very special event. It's been really enjoyable for me. 30 years ago, I first went to CT and to see what's developed. Now, we're obviously celebrating 50 years, but one of the comments I'd like to make is that you all seem to be talking about the next stage and looking forward. So whilst it's really nice to reflect on 50 successful years, it's also clear that this company is determined to move forward in a very effective way. So congratulations on 50 years. Here's to the next 50 from there. And I'd like to thank all of you for watching and look forward to seeing you on the next discussion.